We are starting with our webinar for 3D printing, or understanding how 3D printing can be used to bring better healthcare to Africa. We'll wait for a few minutes for people to join. I see people are joining the webinar as we speak. We will start with a little bit of introduction of where this webinar is placed in our online 3D printing course, and then talk about introduce our speaker, and then go over the fascinating project that our speaker today is going to talk about. So just for those of you who have joined and are not in our course right now, so you can find all information about the 3D printing specialization on our website, which, since we are professors and academics, we've named it 3D Printing Profs. But the course itself, it was actually a package of 5 courses, of which 3 are already available online, and I think many of you might already be enrolled. So 3D Printing Revolution, which is the course where we introduce all what's possible with 3D printing and give you an overview, partly from our perspective, but also from a global perspective by talking to leaders in this space who are doing fascinating stuff, and sort of our perspectives on why 3D printing is a revolution. The second course on 3D printing applications is what I lead, where we talk about different applications across different industries. And one big theme in that is using 3D printing for development. And we have some interviews with social enterprises in India, which are also similar to what our speaker today is going to talk about, are looking at converting waste to 3D printing filament. We've also had a chance to meet the CEO of Tech for Trade, which is also involved in the projects that Crystal will talk about. And we also have our own lab working with partners in Chennai in India, Tanzania, and Argentina as well, where we are setting up remote we call them outposts for our lab. But the mission there is to look at 3D printing as not as a technology in itself, but as an enabler for what we call maker literacy, along with marketplace literacy. So our project there is called the Illinois Marketplace and Maker Literacy Project. And you will, if you're interested to learn more about that, I encourage you to check out our interviews with the founders in 3D printing applications. If you need more information about us, just search for us on YouTube, Instagram, Twitter, and you'll find us and find more information about our courses. So now let me introduce our speaker for today. It's Crystal Kagame, the co-founder of Voices for Africa. And you see my name as well. Professor Eric Reinfleisch, who's the instructor for the first course and also the executive director of the Maker Lab, had planned to make it, but unfortunately he is not able to join us today. So with that, I'll give the stage to Crystal. So Crystal, welcome, and thank you for taking the time to chat with our learners. Could you first start with some introductions?
Yeah, my name is Crystal Kagame. I work with a project called ReFab Dar, and I founded an organization called Voices of Africa. We work on technology and development programs, doing a lot of project management and design from a user perspective of how technologies can be utilized for change. How we can best utilize the newest things that are coming out. So I moved to Africa about how mobile phones were going to change Africa, which is incredible. I mean, if we look at how mobile phones have changed your life and everyone else's in the last 10 years, we see such an enormous change. And in a place where there was so little technological change for so long, there's been this tremendous great leap forward. And in that great leap forward, how do we best utilize these technologies to be able to, you know, save time and save lives and save money, and so that we're able to, you know, work with the bottom of the pyramid in a better way to ensure that they get services. So 3D printing for me is a way to be able to try to look for solutions for the poor, because it can be manufactured on site. So if I need, you know, an irrigation pipe, I can print it. In my case, a lot of people said, what are you doing 3D printing for development for? So through the ReFab Dar project, which I'll talk a little bit about, we came up with 50 different prototypes in different categories. And I worked with Jasper at Reflow, and I worked with Tech for Trade, who developed our e-waste printers, as well as the Thunderhead filament extruder, which now Jasper has operational in India with some tweaks. And we're working on operationalization here of that machining. And then from there, yeah, I decided that the #1 thing that people needed was medical tools. And I decided to look at the 6 biggest killers in Africa, and then try to start looking at partnerships with organizations where we could crowdsource ideas for these medical tools.
Okay.
And then get designs. So that's kind of where we're at today. But I have a presentation. Like I said, I could talk as much or as little as you'd like. I could go on and on about it because I just think it's fascinating.
Sure. Go ahead, and I mean, you can share your presentation with the learners.
Good. Thank you. Here we go. All right. So we are talking about using 3D printing to bring better healthcare to Africa. And the idea behind this is that in Africa, especially in rural locations, you have very disjointed supply chains. So a lot of times they don't have the medical tools that are required for the situation at hand. i.e. you have a pregnant woman, she's going to the local dispensary has nothing in it. 52% of women deliver at home. So there's a lack of medical tools available in medical situations. And part of that is supply chain. Part of that is a lack of design for African needs. So what we started doing through ReFab Dar is we had to start at the beginning, is that, you know, there need to be machines that are able to be created here. Because if we're always importing technology to Africa, we're not going to get very far very fast. So ReFab Dar is, as it says, an urban upcycling initiative. So the idea is that me and you and our brother too drink water out of plastic bottles. I go through about 2 bottles of water a day. I reuse my bottles. However, some people don't. So we're left with all these plastic bottles. And these plastic bottles take up to 100 years to biodegrade. So here you have these, this plastic that's not going away. And in Dar es Salaam, it's clogging our waterways. So there's actually 400 tons per day of this plastic waste not recycled in Dar es Salaam today.
And that's just in Dar es Salaam.
That's just in Dar es Salaam. Okay. So if we recycled 10% of that, I could make 1 million medical tools a day.
Wow.
That says something, right? So we could do this. This is possible. Like, it seems pretty huge, but then again, like a few years ago, what people are doing on their mobile phones now was pretty unthinkable and huge. So this was a pilot project, and it was originally for 6 months, and then it turned into 12 months, and then it turned into 18 months, and it just finished at the end of February. So we worked in partnership with Stick Lab, which are the local engineers who built the retread 3D printers designed by Tech for Trade. They also built the Thunderhead filament extruder. We work with CosTech, which is the Commission of Science and Technology. That's where my office is, where we have the printers and we do the prototyping and we have our meetings and so on and so forth. We were funded by the World Bank Group. So for those 18 months, I had the privilege of being a World Bank consultant. I wouldn't mind doing that again. That was a very interesting and new thing for me. We got to work with NVU, so we learned a lot about social enterprise, and I had been working in social enterprise before through Voices of Africa. So it all came together, and we hosted it at Boonie Hub, and Boonie Hub is the innovation and tech space, really kind of focused on software, but with a hardware component in Dar es Salaam at CosTech. So we created this project, and over this time, we learned how 3D printing works. And not only did we learn how 3D printing works, we learned how 3D printers work. We learned how filament works. We learned how a number of other machines can work to create jobs and to create this ecosystem of manufacturing. So, you know, we made 50 prototypes. We did 9 training sessions. We trained over 140 people, mostly college kids. We went on field trips. We did designs, and we did a lot of outreach in the community. 3D printing is something no one had ever heard of before. We also did a lot of work with the waste pickers. So the work with the waste pickers was to go out and find out, you know, how do we use this technology to really serve a population that is very hard to serve, that's very hard to bring out of the situation that they're in. So what we decided is that they processed the bottles and we paid them a premium. And we learned that through experimentation. So we worked with a local company called The Recycler, a wonderful guy named Matt Hayden. And he shredded the plastic for us and collected it. And then we were able to start to operationalize this thing that started out as a pilot, kind of like this high risk idea, maybe this thing will work, to we are getting to the point where we have people who can make these things happen. So at this point, we understand how 3D printing works, but the only things that we're able to print are plastic because the machines that we have are plastic. I'm going to go to the 3D Heals conference in California in April. So I'm going to learn about metal printing and going to learn about, you know, tissue printing and even see, you know, what application there would be for that in Africa. But for now, I'd really like birthing kits. And we'll talk about that in just a moment. Okay. So can 3D printing serve healthcare? Like, yes, like there's no question. There's a lot of plastic in healthcare, and there's a lot of things we haven't designed yet. Like we could come up with brand new designs for products that have never existed before, that serve particular functions and needs, that are best made using 3D printers. But that's the next step. That's the next place. Right now, we have an extremely high dependency on imported goods in Africa. Every medical tool that is in Tanzania at this time has been imported. And that should change. In the United States, it would be crazy to think that there were no locally, like, made in the country medical tools. Yeah. Plastics can be printed on site. And it gives us a lot of opportunities to innovate. But again, this is like a blue ocean thing. So we are like this far into something this big. So there's so much we can do. So some of the things that can be 3D printed in medical is, you know, casts. There's a picture of a baby with a trachea here. You see this skull. One of the ideas that I had, and one of the reasons why I wanted to do this project and even research 3D printing, was that I was in a rural hospital on a mountaintop getting an operation.
Wow.
And they didn't have the tools, and it was a teaching hospital, and they didn't have any anatomical models. So I looked online to try to import anatomical models, and I would literally have to buy it an airplane ticket. Ooh. To get one here, because the shipping and the whole thing, it was just absolutely crazy. So this kills two birds with one stone. And it's something that I'm passionate about because I've been in that experience of like, gosh, there were 2 doctors for 500,000 people. And it was the primary where women went to have babies, and they didn't have the basic medical tools they needed. And it's just ridiculous. So here you also see various dragging clamps. There's a lot of prosthetics. There's a lot of hope in prosthetics. I visited both the hospitals here. If we had the money for printers, we would love to work with them, and they would love to work with us. However, it's resource limited. And then, of course, the tissue printing in the last picture here. Right now, we're working with Cambridge University on 3D printed microscopes. So there is a student project that started called Waterscope, and these microscopes are able to detect bacteria in water. And we are testing with Johns Hopkins, JPIGO, to see if they can detect malaria.
Okay.
So we're looking at, you know, producing these not only for that, but, you know, the schools in Tanzania don't have any microscopes. Yeah. So these kids have never looked through them. How do you become a scientist and interested in like these little particulate matters, or interested in, you know, looking at bacteria or germ theory or any of this without a microscope? So these are low-cost digital microscopes, and hopefully they'll work. We start actually field testing them next month.
Oh, nice. Okay, that's great.
Yes. So what's happening now, like I was saying, Stick Lab is making the printers. So we have 5 of them for this JPIGO project that are making these microscopes and are making the medical tools.
Oh, wow.
We are trying to use, as you see here, the Thunderhead filament extruder. We want to use as much PET to make the medical tools as possible. So we're trying to see if we can get the designers to work with us to use PET. But then Jasper is also helping us to see if maybe we can find other polymers through different recyclables that would have different properties. Okay. So I'm hoping that works, because it would be really nice to have like a recycled flex filament, which we don't have now.
And Jasper,
so we've also,
sorry, yeah, I recall chatting with Jasper. So he's working in Nepal or somewhere else in India?
He's working in India. He's working in Mumbai, I think it is.
Okay, okay.
And I'm working here.
So I mean, just to remind the viewers, you're connecting from Dar es Salaam.
Yes, I'm connecting from Dar es Salaam, Tanzania. So if there's issues, it's my internet lag, you know, no, I apologize.
No, I think the connection is pretty good, so you're coming through nice and clear.
I'll tell you, 10 years ago, I couldn't have done this. Yeah. Technology amazes me still every single day.
Absolutely.
Oh, so we're working on creating new enterprises. So we have like a little jewelry company who's doing 3D printing with us. We have people doing other projects. And again, for me, it was all about healthcare. And then the idea is we want to make the printers easier and easier to use so that then we can employ lower educated youth and handicapped people to run the machines to be able to make these products. Nice. So that it wins on every level. I mean, that's really what we're trying to do. So the project we're working on now, since the World Bank project technically ended in the end of February, is on a small grant project from JPIGO. JPIGO, like I said, is John Hopkins' charity arm that works in different countries all over the world. They have a very large profile in East Africa, especially in Tanzania. They do a lot of work in healthcare innovations, and they work in the same target areas, those 6 big killer diseases that I wanted to focus on. So it was a win-win. So we applied for $30,000 in funding, which is like such a drop in the bucket, but we're going to make something work out of this. And we're doing our field testing in Dar es Salaam under the Commission of Science and Technology. We're also working with the National Institute of Medical Research to make sure that we have verifiable publishable results, because it's the first time this kind of study has been done in an East African country, to the best of our knowledge. So we want to, improve people's health outcomes, and the current supply chain is a mess. So, for instance, in order to have the nose of a baby sucked out when they're born, you have to have a penguin sucker, or you have to have something that sucks it. Yeah. So there's a product by Laerdal, which I'll show you a picture of later. And it's a beautiful silicone, reusable sucker in the shape of a penguin. The retail price is $23. The wholesale price is $4. But the lead time from the time of the order to the time of delivery in the country is 6 months.
Wow.
To the time of delivery in country to the healthcare facility is another, depending on how slow the wheels turn, 2-3 months.
Wow.
And these are necessary in the first minute of a baby's life. So if you think about that delay in the supply chain versus lives that we've lost, like it's phenomenal to me.
Yeah.
So basically what we want to do is we want to work on creating medical tools that can be printed on site, low cost, through recycled goods, using the technologies developed by Tech for Trade and the methodologies used by ReFlow to now create these products.
Nice.
And my idea is that we try to build them in as many district level facilities as possible to decentralize the medical supply chain.
Absolutely.
The waste of Dar es Salaam alone, like it says in bold brackets there, that we could supply basically every simple medical tool required in the country off of our own plastic waste, which is pretty freaking incredible. So how this is done, we call it the virtuous cycle. And if you guys have watched the other videos, then you'll already know a lot of this. But we go from plastic waste to the filament, from the filament to the printers, from the printed to the medical supplies. So on this project, JPIGO is the lead. ReFab Dar, we're the technical experts. I work on the policy and work with the government and do all of the webinars like this to try to get support. Stick Lab actually makes the printers. ReFlow and NVU make the plastic filament. And then, like I said, we work with CosTech and with the government and Ministry of Health and all of those wonderful people. So with this research study, I decided that I was going to do something else weird, because that's what I'm known for doing. And I decided I was going to have this hack for health, and I was going to ask designers all over the world, as individuals or as teams or however they wanted to show some love to African mamas and to help us to design some tools. And we had some pretty specific tools in mind. for them to design, but there is some freedom and creativity. If they come up with something that's like absolutely impeccable and amazing, they could win, even if it's not listed here. But we are focusing predominantly on newborn health and HIV prevention. So that is those neonatal aspirators, those penguins replacements, as well as pieces for birthing kits. So we found very nice usable fetoscopes, which are actually currently being tested in 4 medical facilities. Every time I print them, somebody comes and takes them and says, please let me take these to my hospital. We don't have any. And I'm like, okay, but like, so we're getting to the point where we have to start producing them for money because I'm spending a lot to give them to people. Yeah, so the project, the first objective is these microscopes, which are going to be incredible. And we're going to produce those in Tanzania. We have all the parts. We're doing the printing here. We are making them here. They're going to be done using Raspberry Pi. They're going to have little cases and boxes, and they're entirely digital. So they're going to be able to send pictures of the samples. They're going to be able to share, and they're going to be able to view things that they couldn't before. I mean, like, this would have been fantastic when they were dealing with Ebola in Sierra Leone. Like, this is a kind of technology that's fantastic for outbreaks because it's cheap as chips, it's lightweight, you can get it to the field in a day, and then you can share those images immediately. Yeah. So like, what we'll be able to do with this is just like so exciting. Because we're just, again, tip of the iceberg. Of the iceberg. And if anyone would like to download the files for that, who's on the webinar, talk to me, because everything that we're working on is open source. That's what we believe in. We believe that, you know, we're all in this together. We all live on the same planet. We all need a good environment. We all need good health care. So yeah, it's all open source. Now the Hack for Health 3D Printing Design Challenge is, like I said, so we're looking at different tools to go into a birthing kit that maybe we don't already have. So we're looking for submissions in that regard. We already have a fetoscope. We already have needle pliers. Most particularly, we need something for this neonatal suction device right here. I don't know if you guys can see my mouse, but I hope you can. This is really a cute device. They're absolutely darling. However, we need closer supply chain. And the pricing is high when you're talking about in a developing country. The Prepex is a wonderful new technology for adult male circumcision, which has been shown to reduce HIV and transmission. The Prepex itself is plastic, so it costs like $4. That's not a big deal. But the kit that it requires for putting it on and taking it off is $30. Wow. And then those tools have to be sent to South Africa for disposal. So imagine the price of that shipping. Like, it's phenomenal. It's millions of dollars wasted. So we need to design something else to put this device on and off. Simple. I mean, this is not rocket science, but in a way it totally is. And then last but not least is the Mogan clamp. And the Mogan clamp is what is used on the 8th day for those lovely baby circumcisions. And it is a very heavy device. And they are $500 each.
Ouch.
So people don't use them. Yeah. So we need to find something else that does the same thing, because currently that baby might get cut by a traditional blade, or they wait until later in life and they go through the traditional circumcision ceremony, which may or may not, again, be done with a clean blade. So that's HIV and AIDS transmission again. So these are very important tools, but the reasons why we chose these ones in particular is because if we can get these made, then it would show that we could make others. And these are high need things. So these could make, you know, a big difference in a short amount of time. So we're asking people to help with this. Anybody? And that would be wonderful. And so, yes, the next thing is if people want to help us, if they want to participate, I am all about the volunteer mentality. If people want to come to Tanzania and help me, karibu sana. Nyumbani yangu ni nyumbani yako. My home is your home. We also have houses. We can also work in Mombasa. Mombasa Raha ni marembo sana. Very beautiful. Yeah. So yeah, everybody come visit me in Africa. We have websites. There's a link here for our events. I don't know how to follow links if I can. We have a Kickstarter, which is not going well. And I'm not particularly good at these things, but we're trying to raise $15,000 to buy the machines that we need to build better machines to make better products. Does that make sense?
It does. It does. I think I've in the chat I've shared some links which all our viewers can actually click on as well. And if you, Crystal, if you want to just open up the chat panel, on the button is right at the bottom next to the share screen button, and then you'll see the conversation happening, and a few questions are also coming in.
Oh wow!
Yeah. So, I mean, before we start with the questions, I mean, it's amazing work that you're doing, and some of the, sort of touch points that I see with the work, of course, the course, we've already told our learners about, your work, and this webinar will be recorded and put inside the course as well. In terms of, possible touch points outside of the course as well, we are working with Oikos in Tanzania for the marketplace and maker literacy project. So I'll make introductions, and if that is a touch point, because we are looking at that is focused at low income, low literacy populations, and then 3D printing is looked at as a way to, as you said, produce in place rather than, and make in place, and look at how you can empower people to use new technology to create, solve their problems, forget about creating businesses or something, solve a problem that you can locally. So that would be an interesting thing. Another, point where we can help is, I teach a course on campus where students find problems to solve and design things for them. I think this project would be great for them. Much more meaningful than creating a new bathroom toilet tissue holder.
I have much more challenging projects than that. Yeah, for sure. Yeah. For sure. Yeah. We could even do custom design, because I do a lot of work here with the handicapped. Okay. And I would really like I think it would be nice if we could use a technology like this, and connect the students with someone that they could help.
Absolutely. I think that would be great. So we can, we'll talk more about that. Let me go through some of the questions that came in. So we have about, 22 people with us right now. We have, folks from India, from Germany, from Honduras. We have actually one, Louis is here, and he was recommending, he's actually working on the marketplace literacy project in, I believe in the Honduras. And there are two, so Alicia and Louis are both from there, and they seem to be connecting and sharing notes. Louis is also recommending you try Indiegogo for fundraising instead of Kickstarter, or maybe in addition to Kickstarter. And let's see, there was a question earlier about This is from I mean, if people have more questions, please keep typing in the chat.
Well, thanks for all the praise, though. That's very nice.
So Alicia,
I mean,
yeah.
It's just a labor of love, you know, like I like what I do and it makes me happy and it solves a need and I hope I can continue to do it. That's
So Fred had a question. How do you sterilize PET medical tools?
So now, that is a very good question. And that is something that we're experimenting. So PET, so when you're using plastic, it obviously melts. So you can't put it in a HIPAA cleanse, which I've tried. So that one was not going to work. So the second part was we're looking at different baths. So we're looking at different chemical baths to see how it would sterilize the PET tools. And then alternatively, we're looking at a third solution, which is we make the PET tools into one-time use tools. We then recover those PET tools. We then take those PET tools, grind them up again, turn them into filament, and then turn them into something non-medical. Does that make sense?
Yeah. So, I think next we have, I think it is, Zamira was asking about the link for downloading the file. I think you were referring to the fact that these are open source designs, and I shared the link to the design challenge, but I don't know if that's the right page where people can download files from, or if you want to share the URL in the chat, that would be great.
Yeah, let me do that now.
Okay. And I'll go ahead and read the next question as well. So Vito is wanting more information about the high need products you talked about, and he's offering to help design them. I believe he's based in, they have a product design, product development and 3D printing firm, and he's given the link to his website. That's Hononga, I believe. So
yes, so I would recommend that he please join the design challenge.
Okay.
And he can have his own team, and yeah, and then it would be wonderful if they could come up with some amazing designs, because I'll be taking a sampling of all the best designs with me to California to 3D Heals.
Nice. Yeah, 3D Heals sounds like I think that's April 19th and 20th, right? I shared the link for that as well earlier in the webinar.
Yes.
I mean.
Yes, I'm so excited. And I'm excited to mingle with other people in this field, because I'm in Tanzania. Yeah. There's 2 3D printing projects ongoing in Tanzania, and it's me and my friend Beth, and she has a company that sells Ultimaker. So it gets kind of lonely.
Yeah. We actually have all Ultimakers in our lab as well. So that's, Ultimaker is one of our partners for the online course on hardware.
I love them. They can send me as many as they would like.
Sure.
And I will not complain.
We will certainly make a request to them.
Well, I have too. We just keep requesting over and over. One day they'll give in.
Sorry,
let me send also the Wevolver links.
Okay.
If anyone is interested in the printers, or the Thunderhead filament extruder.
Sure.
Because I think that our friends who are working in Latin America could definitely use these designs.
Absolutely.
And if they're crazy enough to do it.
I think in our local, I mean, we don't need to consider these solutions only for remote locations. This is a solution that will work here, because every summer we generate thousands of bottles with all the summer camps. And we were looking at last summer with our local fab lab to, sort of a DIY filament recycler instead of, purchasing one in the market. But we didn't get that done last summer. So maybe this summer we'll try this.
Oh, yes, please.
Yeah.
That would be awesome.
Yeah.
For you and for us. So I'm going to go ahead and send, let's see, let's open the links. Sorry, it takes me a minute to get there.
That's okay. So Piyush he's in India, had a question about can recycled 3D printed plastic be used for prosthetics?
I really, really, really want to try that.
Okay. I mean,
so the answer is hypothetically, yes. I know? No.
Okay. I mean, if the feedstock is getting converted to regular filament that goes inside a 3D printer, I mean, we have projects like Enable the Future, which are, doing prosthetic hands, low cost and not that high in functionality, but that's, good enough for people who don't have access or can't afford, $1,000 prosthetic hand. So there are projects, and Piyush, if you want to look inside the 3D printing applications course, you can, or just search for Enable the Future and you'll find their experiments with prosthetics with just regular home 3D printers.
I'm having a problem opening the retread. So I'm having a problem with these links, but if you look on Wevolver, so I'm going to post the Wevolver link. Okay. And if you search for retread, and the Thunderhead.
And I'll save all these links for later and share that.
Oh, I really like this new question. Is it difficult to introduce such new 3D printing technologies in countries that are not democracy? Edward, okay, so yes and no. So when you work in frontier technologies, you work in high risk everything. Yeah. So they could say tomorrow, we don't like your technology, leave. Or they could say, we love it. Please tell us how to write policies about it. In Tanzania, I've been blessed in that I work with the Commission of Science and Technology, and I work with the it's called the Dar Technohama Business Incubator, DTBI. And so I have some people who are pretty powerful within the government, who know that there are no policies and there are no procedures and that there's nothing for us to follow. So they said, just, we document everything we do, and then we let them know what we recommend that they do for the next people who want to be like us.
Nice. Yeah, that's great. I mean, there are, I think the part perhaps where we can help is also connecting the dots with these different projects across different countries. So we are trying that, with webinars like this, and also I think for example, in our first course, we've had over about 10,000 people enroll in that. In the 3D printing applications and our software, it's close to 6,000 people who have taken it. So there's a big global audience. This is across the world. So we'll certainly help spread the message this way, and several other attempts. And it'll be great to have our learners involved in these competitions and these projects, and because we also have a capstone at the end of this specialization. Yes. So now this kind of a prompt or a context would be great. And actually the director of our local Fab Lab will be leading the capstone. So I'll certainly share this with him as well. We had, Um, Lewis, who's again in, I forget where Lewis was from, Honduras.
Did I miss one?
He is talking about any problems with existing medical device suppliers now that you're thinking of local, solutions and local printing.
There are no local medical manufacturers. There are no tools made in Tanzania.
Okay, so that's not a concern. Piyush was suggesting he's experimented with metal coating on plastics, which helps with strength. You could try that.
We could try that. We have not yet, but that's like, I need to learn about 3D printing and plastics.
Yeah.
Again, I'm in Dar es Salaam, so like I only have access to so much. My printers and Beth's printers. So I'm really good with those. When I learn metal printers, I would love that. Love that. I would love to be able to make metal tools. And maybe at some point we can, but we're not there yet.
Yeah, I think with the patents having expired on some of the metal printing, you are looking at desktop printers, which are, good. Or, I mean, we've also in the Maker Lab itself, we've explored printing with plastic filament mixed with carbon fiber to make it stronger. So those still work on, standard FDM printers. That might be an option to consider as well. So, just composite filament that can print stronger materials. Yeah.
Yes. Jasper and I will be working on that. He has an intern who's a polymer scientist, and I keep disturbing him about the strength issue and flex. I want to figure out what polymers we can mix together to make flex that's not PLA.
Okay. One last question we had. Vito is asking, how much does it cost to produce a kilogram of filament from recycled PET?
Okay, so now that's kind of a complicated and kind of an easy question. So if you include the price of the extruder should cost about $2,000 to build.
Wow.
So if you were making 2,000 and you make maybe, let's say, 10 rolls of filament a day. So maybe you say there's $1 for the machine. Yeah. And then the waste pickers, they make about 300 Tanzanian shillings per kg of plastic. And it takes 2 to 3 kgs of waste plastic to create 1 kg of filament. So that would be 1,200 Tanzanian shillings, which is approximately 60 cents.
Okay.
Yes. And then you want to add about another 20 to 40 cents for the washing, because it has to be really, really clean. So you have to use some detergents. And I'm looking at what are the best, most natural detergents as well to be able to use. But we are, so this detergent. So I say about $2, and then labor, of course.
Yeah.
So it depends on what you pay for labor. Here in Dar es Salaam, it's, let's say, they'd be really happy with $2 an hour, which would create a roll. So $4, $5 for a kg.
Yeah.
Production.
Okay.
Yeah. Jasper has better numbers on that than I do.
Yeah. So that's.
But I have the more practical numbers from like running around buying plastic and asking the waste pickers and
So I'll share Jasper's Twitter handle as well. So we have Jasper on a talk with us earlier. We recorded him. His talk is also inside our course. Couple of questions from folks in Africa asking if you're expanding beyond Tanzania.
I'm hoping to.
Maybe
somebody want to find me some funding. I'm coming. Yeah. I would love to. I would really love to. And most definitely we're expanding into Kenya. So we're going to have Kenya and Tanzania, at least.
Yeah.
And I would really love to be in 50 countries in Africa, because I feel like every city could use what we're doing.
So, I mean, if you sort of have a playbook reasonably, put down for how to do this, perhaps, these people can just volunteer to start local efforts to replicate these efforts, right?
That is what we're working with Reflow and Tech for Trade on. Yes.
Okay. So,
Excuse
bless
me.
you. So I guess in terms of contacting you, would email be the best one, or is there a sort of a community or a mailing list, something they can sign up for?
They can go to the Voices of Africa website and they can sign up for that mailing list.
Okay.
They can email me at crystal@voicesofafrica.org.
Okay.
They can send me contact through the ReFab Dar website.
Okay.
Anything social as well. I'm easy to contact. That's not, as long as you're nice, I'll reply, right?
No,
if you say something nasty, I might not.
Yeah, I remember I reached out to you through Facebook Messenger with a cold message.
Exactly. Like I'm pretty reachable, because you never know.
Yeah.
There could be my millionaire donor out there saying, I just wish somebody wanted to make 3D printed medical tools in Africa.
Yeah.
And I have to be open to that.
Absolutely. Yeah. No, we certainly appreciate your passion, and we hope we can help you with your cause any which way possible. So we will, I think we've taken most of the questions. So I'll, you have a contact. If you look up on this chat itself, you'll find all the links and emails. But if you also want, let me share our contacts here. You can find, Crystal at Voices of Africa on Twitter as well. And of course, you can reach out to me on Twitter, or those of you who are inside the course will also have access to my email, or, I'm also fairly findable. So if you need to connect with us at the Maker Lab, just find me or us on makerlab.illinois.edu. That's our URL. So it looks like a couple of folks will be contacting you, Crystal. So thank you so much for spending the time with us. We really appreciate, you sharing your passion for this. And we hope, we can continue to drive some of our learners to your cause.
Thank you so much, and lovely to be able to do this. It was very fun.
Great, thank you so much.
Thank
you to all our viewers as well for listening in and sharing your suggestions. If you're not already in the course, you can just search for us on Coursera with 3D printing, or our website 3D Printing Profs, and sign up for this course. If you sign up, here's a trick. I shouldn't be saying this on air. If you sign up for these individual courses, you can get in with just the audit version, where you don't have to pay for it until you're sure you want to pay for these courses. So if you want to get in without paying for it, go into an individual course. So just search for 3D printing applications, where you'll find this talk in about a week or so, and other discussions on 3D printing for development. And if you like it, you can stay for the rest. The 3D printing hardware course will be launching pretty soon. And then the capstone, where you will put everything together and, do some, solve some problems across the globe. So we hope that. So thank you for joining. And there are some, Louis is sharing some WhatsApp contacts for the Honduras folks. Please connect and share. And we will see you in our next webinar.
Thank you all. Nice to see you.
Bye-bye.
All right. Bye.